Let's say that we've got the function y is equal to 5 times 2 to the t power. And someone were to come up to you and say, hey, look, this is an interesting function, but I'm curious. I like the number 1,111. And I'm curious, at what point, for what t value, will my y be equal to 1,111? And so I encourage you to pause this video and think about it on your own. At what t value will y be equal to or roughly equal to 1,111? And if you see the need, you might want to use a calculator. So I'm assuming you've given a go at it. Let's work through this together. So we want to say, when does 5 times 2 to the t power equal 1,111? So let's write that down. So when does 5 times 2 to the t power equal 1,111? So whenever we're doing anything algebraically, it's always a little bit useful to see if we can isolate the variable that we're trying to solve for. We're trying to find what t value will make this equal that right over there. So a good first step would maybe try to get this 5 out of the left-hand side. So let's divide the left by 5. But if we want to keep this to being an equality, we have to do the same thing to both sides. So we get 2 to the t power. 2 to the t power is equal to 1,111 over 5. So how do we solve for t here? Well, what function is essentially the inverse of the exponential function? Well, it would be the logarithm. If we say that a to the b power is equal to c, then that means that log base a of c is equal to b. A to the b power is equal to c. Log base a of c says, what power do I need to raise a to get to c? Well, I need to raise a to the b power to get to c. A to the b power is equal to c. So these two are actually equivalent statements. So let's take log base 2 of both sides of this equation. So on the left-hand side, you have log base 2 of 2 to the t power, and on the right-hand side, you have log base 2 of 1,111 over 5. Now, why is this useful right over here? So this is, what power do we have to raise 2 to get to 2 to the t power? Well, to get to 2 to the t power, we have to raise 2 to the t power. So this thing right over here, just simplifies to, this just simplifies to t. That just simplifies to t. And on the right-hand side, we have log base 2. We have all of this business right over here. So I'll just write it over. T is equal to log base 2 of 1,111 over 5. So this is an expression that gives us our t value. But then the next question is, well, how do we actually figure out what this is? And if you take out your calculator, you'll quickly notice that there is no log base 2 button. So how do we actually compute it? And here we just have to apply a very useful property of exponents. If we have log base 2 of, well, really anything. Well, let me write it this way. If we have log base a of c, we can compute this as log base anything of c over log base that same anything of a. This anything has to be the same thing. And our calculator is useful because it has a log. The log, when you just press log, it's log base 10. If you press ln, it's natural log or log base e. I like to just use the log base 10. So this is going to be the same thing as log base 10 of 1,111 over 5 over log base 10 of 2. So we can get our calculator out. And we could have done log base e if we wanted. That would have been natural log, but I'll just use a log button. So this is logarithm of 1,111 over 5. So that's this part right over here. This is log base 10 implicitly. That's what the log button is. Divided by log base 10 of 2. And then that gives us 7, well, it just keeps on going. This is approximately equal to 7.796 I'll just 7.796. So this is approximately equal to 7.796. So when t is roughly equal to that, you're going to have y equaling 1,111.